Newton's third law of motion. Newton's first two laws of motion inform us about force and effects of force on the motion of objects. Newton's third law of motion describes the relationship between the forces on two interacting objects. Force never occurs singly in nature. Force is the mutual interaction between two bodies. Forces always occur in pairs. The forces between two bodies are always equal and opposite. This idea is stated in the form of Newton's third law of motion. The Newton's third law of motion states that to every action there is an equal, opposite, and instantaneous reaction. Action and reaction are the terms explaining force. These forces exist in pairs. An isolated force does not exist. These forces act at the same instant. Action and reaction forces act on different bodies. They don't act on the same body, hence they don't cancel each other. Newton's third law of motion. Examples. Here are some examples that can throw some light on Newton's third law of motion. 1. When a bat strikes a ball, the ball also exerts an equal and opposite force of reaction on the bat. The force acting on the ball projects it with high velocity, while the reaction force acting on the bat slows down its forward motion. 2. When a bullet is fired from a gun, a force is exerted by the gun on the bullet, and therefore the bullet acquires high velocity. At the time, the bullet also exerts an equal and opposite force on the gun, and the gun moves in the opposite direction with small velocity. 3. The principle used for the motion of a rocket is based on Newton's third law of motion. When the fuel in the rocket is ignited, it burns as a result of chemical reaction. The exhaust gases escape with force through a small opening at the tail end of the rocket. They exert an equal and opposite reaction force on the rocket. It is this reaction force which makes the rocket move in the forward direction. Principle of conservation of momentum. Consider two objects, A and B, having masses m1 and m2, moving with initial velocities u1 and u2 respectively. The values of initial momentum are m1 u1 and m2 u2 respectively. When they collide with each other, a force F1 due to body B acts on body A. The body A accelerates. Its velocity after collision becomes v1. Hence, the momentum changes to m1 v1. According to Newton's third law of motion, body A also exerts equal and opposite force on body B, and it also suffers a change in momentum. Suppose its velocity becomes v2 and momentum changes to m2 v2. If F2 is the force acting on body B, F2 is equal to minus F1. M2 A2 is equal to minus M1 A1. Substituting the values of A2 and A1 in this equation, we get M2 multiplied by the difference of V2 and U2, the whole divided by T, is equal to minus M1 multiplied by the difference of V1 and U1, the whole divided by T. On multiplying both sides by T, we get M2 multiplied by the difference of V2 and U2 is equal to minus M1 multiplied by the difference of V1 and U1. Therefore, we have M2 V2 minus M2 U2 is equal to minus M1 V1 plus M1 U1. On adding m1 v1 and m2 u2 on both sides, we get m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Therefore, we have final momentum is equal to initial momentum. Hence, the total initial momentum is equal to total final momentum if no external force is acting on the two bodies. This is also true for any number of interacting objects. If there is no net force acting on two interacting bodies, then their total momentum is conserved. It is the corollary of Newton's third law of motion. Momentum is always conserved in a collision. The momentum may get redistributed among the colliding bodies. One body gains momentum lost by other. Hence, the principle can also be stated as: if two freely moving bodies collide, their total momentum after collision is the same as their total momentum before collision. The principle can be explained by an example of a bullet fired from a gun. When a bullet of mass m1 is fired from a gun of mass m2, it acquires velocity v1 and moves in forward direction with momentum m1 v1. As initial momentum of both gun and bullet is zero and no external force is acting on them, total momentum is conserved. After firing the bullet, the gun moves in the backward direction. The motion is also called as recoil. It moves with recoil velocity v2 such that m1 v1 plus m2 v2 is equal to 0. As mass of the gun is much greater than mass of the bullet, velocity of the gun is very small as compared to the velocity of the bullet. So, momentum of gun and bullet is equal in magnitude and opposite in direction. Hence, there is conservation of momentum. In rocket propulsion also, the principle of conservation of momentum is followed.